Okay, so this stuff is a little bit out of the scope of this unit, but we're gonna go ahead and solve some complex equations. These are gonna look a little bit different than the standard equations that we've been solving. And then we're gonna look at some literal equations, how to solve equations with no numbers in them. Well, partially with no numbers in them. This one has the half there, okay? So, I just want to show you that you could solve these complex equations just by following the same rules that we've been following, all right? Always try to start with addition and subtraction first. If not, try to do your PEMDAS, all right? Remember, the goal is to go ahead and solve for x. So let's start our first one. We have x plus 5 divided by 6 is going to be equal to 10, okay? So this is just a quotient. There's nothing being added to it and there's nothing being subtracted from it. There is something on the inside, but we can't get to that yet. We have to get rid of this 6 in order to get to what's inside over here. And this right here is showing division, so I'm going to go ahead and multiply. So multiply this by 6 and multiply this by 6. That cancels out, so x plus 5 is going to be equal to 60. Okay? Now from just doing that one step, this problem is easy now, all right? We just have to minus 5 here, minus 5 here. So then x is going to be equal to 55. All right, let's plug in and see if that makes sense. 55 plus 5 is going to be equal to 60. 60 divided by 6 is equal to 10. So when we plug in, we see that we have the same answer. Let's try another one, same concept. 3x plus 2 divided by 2 is going to be equal to 14. Okay, so same concept. We have to get x all by itself. But in order to do that, we have to free up this 2 over here. So this is showing a quotient, which is division. So I'm going to go ahead and multiply by 2. Multiply by 2. So now I have 3x plus 2 is going to be equal to 28. All right, now I'm going to subtract 2 and subtract 2. I have 3x is going to be equal to 28 minus 2 is 26. I'm going to divide by 3 and divide by 3 here. So x is going to be equal to whatever 26 divided by 3 is. So 3 goes into 2 0 times. 3 goes into 26 8 times in order to equal 24. We have a remainder of 2, so I'm just going to go ahead and add my decimal. This goes 20. 3 goes into here 6 times, which is going to give me 18. And then 2. So as you're going to see, it's going to go ahead and repeat. So I could either write 8 2/3, or I could write x is equal to 8.66. Okay, so either or works. All right. Okay, so let's go into our third one. And as you can see, this one's a decimal. It's okay. All right, it's okay if these are fractions or decimals. Let me make number 3 a little bit more complicated. Let's say we have 2 plus 6x minus 7 divided by 3 is going to be equal to 14. Okay, I just did it one step further. Now it's not just a quotient equation, it's a quotient plus a constant. So I'm going to go ahead and take away that constant first, so minus 2 minus 2. Now we have 6x minus 7 divided by 3 is going to be equal to 12. Okay? We have to get to the x, so we have to multiply 3, so times 3 times 3. We have 6x minus 7 is going to be equal to 12 times 3 is 36. Okay? Now, let's just continue to try to get the x by itself, plus 7 plus 7. Alright, so that's going to be 7, 8, 9, 10, 11, 12, 13, 43. 6x is equal to 43. Now, let me go ahead and divide by 6. Divide by 6. It would be nice if that was 42, but that's not the case. So divide by 6. This 6 goes into 43 7 times to equal 42 with a remainder of 10. This goes in 1 time, 7, that's going to be 30. And this goes in 5 times. So your answer is going to be 7.15, or x is equal to 7 15/100ths. Simplified, x is equal to 7. If we divide by 5 and divide by 5, 3 over 20. Okay? You could put it in whichever form you like. If you're going to put it in a mixed number, though, it has to be simplified. Okay? So as you can see, they're not that bad. They're following the same rules. Now, let's talk about some literal ax plus b equals c. We're going to go ahead and solve for x. Now, what that means is that we want to get x by itself, okay? Now, in order to do that, I need to get rid of this b. So I'm going to subtract b and subtract b, okay? I don't know the value of b, so it's just ax equals c minus b, okay? That's the main difference. If you have just nothing but pure letters, nothing but pure variables, some of them aren't going to disappear. They're just going to be rearranged to the other side of the equation. Okay? Now, I want to get x by itself. This is showing multiplication, so I'm going to divide by a, divide by a. So x is equal to c minus b over a. Okay? That's it. We don't know these values, so we can't really do anything else. We can't simplify it any further. We solved for x. Okay? Now, let's say area is equal to 1/2 base times height. We're going to solve for h, okay? So this one is a bit more complicated, okay? Now, what I'm going to do, I have to get h all by itself, okay? So I could divide, I could actually multiply by 1/2, by 2 over 1, and by 2 over 1. So I have 2a is equal to the base times the height, okay? I just had to do the reciprocal in order to get rid of that half over there, okay? Because what it's basically saying, if you rearrange this, area is equal to base times height divided by 2, okay? So all I did was multiply by 2 on this side, multiply by 2 on this side, so 2a is equal to b times h. I hope this lets you see it a little bit better, okay? Now, we simply just have to get h by itself, so divide by b. Divide by b. H is equal to 2a over b. Once again, we don't know the value of a, we don't know the value of b, we don't know the value of h. So, this is our answer. And that's it. We'll practice a little bit more in class.